Hey everybody, this is Dr. Ban again, and we're covering some problems in from the end of chapter 16 that seem to be problems that people had problems with. And one of these is 1689. And again, some of these problems are also can be found. I did put the answers to the problems from chapters 15, 16, and 17 at the end of in Blackboard. So if you have questions on some of those, you can also look there or send me an email, and I'd be happy to answer those questions. So this one will do. So the question is, what is the pH of a solution prepared by mixing exactly 65 mils of 0.2 molar acetic acid with 22.5 mils of 0.4 molar potassium hydroxide? The Ka for acetic acid is 1.8 times 10 to the minus fifth. So let's just draw the dissociation of acetic acid. So we've got H, and I like to draw, write this as CH3COOH, because that's what acetic acid sort of looks like. C double bond OOH, and it's got a CH3 over here, and H's are out like this. And this is called a carboxylate. Anyway, that's acetic acid in it. You add water, like we do, and this would be forming CH3COO minus, which is the conjugate base, plus H3O plus, and the Ka is a monoprotic acid is going to be 1.8 times 10 to the minus fifth. 10 to the minus fifth. So, and it says that we've got 65 mils of 0.2 molar. So we've got 65 mils. So 65 mils times 0.2 moles per liter, and that's so 65 mils, this is 0.065 liters. So we go to our handy dandy calculator here. So we've got 0.065 times 0.2 moles per liter, that's 0.013 moles. Okay, and so we've got 0.013 moles of acetic acid, and we're going to add to that 22.5 mils of potassium hydroxide, which is a strong base, and it completely dissociates. Okay, it's not a weak base; it completely dissociates. So if we have 22.5, so 22.5 mils of that times, what was the concentration? 0.4 molar, 0.4 moles per liter equals, and again this is 0.0225 liters. So we can figure out how many moles we're adding. That's 0.4 times 0.0225. So that's 0.009. 0.009 moles of OH minus. Okay, so we've got and what we're interested in, okay, the question is, what is the pH? So we're going to be, in this case, we're going to be adding some base. So, and the equation that we, is asking for the pH. We're given the Ka. We're also given moles of acetic acid to begin with, and after we've added some base to that. Okay, so the equation that we're probably going to end up using is pH equals the pKa plus the log of A minus over HA. So the pKa of this is, if we wanted to calculate the pKa, that's 1.8 exp5 negative. And we're going to take the log of that. That's 4.744 equals the pH plus the log of A minus over HA. So let's say we've got 0.013 moles of HA to begin with. And we're going to add 0.009 moles of base. So that means that we're going to be converting 0.009 moles of HA, okay, into A minus. Okay, so we're going to be removing this proton, and we're going to be forming the conjugate base of acetic acid, so that would be acetate. So we're going to be moving, subtracting 0.009 moles from here. Okay, in terms of A minus, we didn't have anything to start off with, so A minus is 0, and we're going to be adding 0.009 moles of, we're going to be moving 0.009 moles, since we're, this is our total moles of acetic acid that we've got. So 0.009 moles is now acetate, okay, and so that's going to be acetate. So A minus, this is 0.009, and the amount of HA that is left after that is 0.013 minus 0.009, which is 0.004. So now we can divide this by our total volume, which is 65 plus 22.5, which is 87.5, so that's 0.0875, 0.0875, and so we could put our concentration of A minus and HA in here. So so let's clear. So that's 0.009 divided by 0.0875. Let's point. So we'll go up here 0.103, and the HA is going to be 0.004 divided by 0.0875. It's 0.045. Or 0.0457. Okay, and so we take, we're gonna so we're gonna take 0.09 divided by 0.0875, divide that by 0.045 equals 2.25. We're going to take the, so that's, this is pH equals 4.744 plus the log of 2.25, and we're going to take the log of that, 0.352 plus 4.744 equals the pH. So the pH is going to be 5.09. 5.096. Yeah, 5.1. Okay, it's close enough. So that's the answer to that one, and I think we might have finished out our problem. So I'm going to go ahead and send these out to you guys, and if you have ones that you want me to work out tonight that you feel like I can't get, I'll probably be up for a while, so just let me know. Bye.